Hi, I'm Dean Bushmiller with Expanding Security, and this is Computer Networking Protocols. Now, if you're not seeing the full version of this, go to expandingsecurity.com and you can get quizzes, badges, and this mind map with all the dynamic links in it. Normally, when you hear me say all the dynamic links, you're like, well, you know, that could be anything. But in this case, it is really special because I've got some great information for you when it comes to Wireshark. So let's get started. Computer network protocols. Well, the concept is, well, do you know networks at the packet level? And by the way, Wireshark is your friend. Let's be clear. We are discussing each one of these protocols as a group of networking protocols. There's an individual discussion on each one of these protocols and a detailed Wireshark analysis of each one of the protocols in a completely separate video. So we're collecting these together and working on them as a unit. We will take a look at the packet structure here. And before we go any further with the packet structure, I did want to flip over to Wireshark for a second so that we can understand exactly what's going on here. Now, this is a series of hexadecimal representations, and that's almost perfect computer language. Because remember, it's really going across the wire, it's a series of bits. But as soon as it hits layer 2, it gets converted into something else. So you can see beside me right here, you can actually get the data panel if you want to. I'm in a server message block message, so it really isn't going to make sense unless we actually look at the data inside of there. And I'm sitting inside of here, and I'm looking at the Ethernet address. So you can see when we go ahead and slide this panel over, because nobody wants to read the hex. Well, some people who like, you know, TCP capture and TCP dump, they like to go ahead and look at it that way. I'd much rather have this interface right here. So you can see that we have both a source and destination address here. You can see the destination is there, and you can see the source is there. We can say, oh, this is a VMware client, this is a Palo Alto network that have communicated back and forth for server message block. That's our layer 2 protocol. Then we go up to Internet Protocol, and we can go ahead and see source and what is that long string? Oh, we need to talk about both IPv4 and IPv6 today. So that's going to complicate our discussion a little bit because we're going to have to break back and forth until we get up to the TCP layer when that goes away. Actually, no, it doesn't, because we have to consider IPv6 and IPv4 when it comes to DNS. So we're going to look at those protocols and dig into each one of those protocols. But I'm not going to do it at the packet level. Again, there's a whole separate presentation on that. So we're looking at this from a network standpoint. So Wireshark is your friend, and I'll show you a little bit at the end on how it can become your best friend. When we talk about IP, we're talking about the purpose of logical addressing, packet delivery across the network, fragmentation, and reassembly. That's what we need at that point when we've gotten past the Ethernet address. There are 2 different versions right now, version 4 and version 6. For ICMP, the purpose is error reporting diagnostic message. You know, the application that we use, ping, okay? It's a network layer protocol, and it's encapsulated in an IP packet. It has versions that go along with version 4 and version 6. We'll see how they differ in the next section. For TCP, it's reliable data transfer service. It guarantees data delivery, detects problems, and repairs data transfer problems. It's not looking at failures of the physical wire itself. It protects against loss, duplication, errors from IP layer. That's all it looks for. It is a connection-oriented protocol, and that connection must be established before sending any data. It's a byte-oriented protocol that transfers data as streams of bytes. So sometimes you'll hear people say the TCP stream. It identifies data by byte number, and the receiver application processes the stream as TCP passes up. It does not interpret the contents of the bytes. It does not look at those bytes. It just flows them across. It is a full duplex service, and that means that data can flow independently in each direction, so we need a signaling methodology, which we'll talk about. It provides the service to the applications, and that enables all the upper layer protocols to use its reliable services. And so a lot of upper layer applications depend upon that. The applications are written to take advantage of those services and how that service stack is implemented on that particular computer. Next, we go to UDP. Its purpose is for minimal transport layer protocol. What's the least that we can do here? And it is a connectionless communication. It is a best efforts delivery. Its characteristics are no connection establishment, no reliability, no ordering. This doesn't feel like a very good protocol, but the reality is it's got a low overhead and it's suitable for latency sensitive applications. Now, I put DHCP, BootP, and APIPA all on the same line. We're really only going to talk about DHCP because it's the major function that we perform. But remember, there are 3 different protocols that do the same thing, which is enabling the IP address to be configurable on the client without actually physically manually being there for the client. It gives standards for addressing, configuration, and assignment, and it stops all that manual process for us. And it can provide lots of optional parameters, which we will talk about. Lastly, DNS, which I think if you only understood one protocol, it would be DNS. If you only understood one service, it would be DNS. From a security standpoint, it runs the internet at this point in time. And from a security standpoint, if we can control DNS, then we win. All it does is resolve host names to IP addresses. The structure of it set up in a hierarchical distributed system between all the servers that do this resolution for us. That would be like your root domains, which are the dots, the top level domains, which now there are hundreds of them at this point, but it used to be .com, .edu, .mil, and then all the countries that were out there. And then the second level domains would be something like expandingsecurity.com. Operationally, it does a query response model and it does caching and recursion. So I hope you'll join me for the entire presentation.